Welcome to today's webcast, brought to you by Progress DataDirect. I'm Stephen Faig, Business Development Manager at Unisphere Research and Database Trends and Applications. I will be the host for today's broadcast. Our presentation today is titled Big Data Trends and Open Standards, Why You Should Care. Before we get started, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentations, just type it into the question box provided and click on the Submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, one lucky viewer today will win a $100 American Express gift card. The winner will be announced at the end of the event, so stay tuned to see if you've won. Now, to introduce our speakers for today, Jesse Davis, Senior Director, Research and Development at Progress DataDirect, Sumit Sarkar, Chief Evangelist, Data Connectivity and Integration at Progress DataDirect. For more information on our speakers today, you can click on the speakers icon at the bottom of your console. Now to pass the event over to Jesse.
Thanks, Stephen. Hey guys, welcome to our webinar today. We're looking forward to seeing you guys and talking with you a little bit about the big data world and what we see in regards to open standards connectivity. My name is Jesse, as Stephen said. I've been working here for a long time in the data land for about 20 years. And when I'm not making fun of Sumit on my Twitter feed, I'm running an R&D organization trying to help customers get up and running, connected to their big data systems, to their relational systems, to systems in the cloud. I've been working on the standards bodies for quite some time. I'm really excited to come to you guys today and tell you what we've got, what we've seen in the industry, use cases on real-world scenarios our customers are hitting, and what we see in the future for these standards in relation to the big data world. Sumit?
Hey, thanks, Jesse. I'm Sumit Sarkar. I'm the Chief Data Evangelist for DataDirect. I've been working on standards-based connectivity for over 10 years. And in my role, I get to talk to shops about data standards, which cover a lot of technology ground. And I recently presented at Dreamforce to talk about OData, Hadoop Strata. We did a little bit of JDBC. And next month, I'm excited about MongoDB World, where I get to present about OData. And you can follow me on Twitter at S as in Sumit, not Jesse. All right. So in talking about the standards and DataDirect's leadership in open data standards, a lot of people don't know some of our involvement in these standard bodies. And DataDirect is what we call a vendor-neutral vendor. So we have a storied history with open data standards. The founder of DataDirect, founder of DataDirect, John Goodson, also co-founded the ODBC spec back in 1992. And he kills me a racquetball every Saturday morning. And we are also the first members on the JDBC board that dates back to 1997.
Yeah, one of the other things more recently, that's a little bit of history for you guys. Some of the newer standards, OData is an up-and-coming standard. It's been around for a few years. Originally started by Microsoft, loosely based off of the ADO.NET Entity Framework model for data. One of the things that we were looking for is ODBC and JDBC are very much tuned towards relational databases, have been for a long time. So one of the things we're going to talk about today is how that merges into the back-end systems that are tailored more for specialty types of data access, things like VoltDB and Hadoop and stuff. But on OData, it's more of a standard over REST. So OData is a REST-based standard. Microsoft went through the process of making sure that thing was cleaned up and wanted to make it into an open standard. So they needed other people to join with them. SAP was involved pretty early on. We went out and had a meeting with Microsoft. They asked us to co-found that as they moved that standard into Oasis. And since then, they've added a bunch of other people on there. You know, OData feeds are available from Netflix, which is some of your online repositories of information, all the way up. SAP has it available for their stuff. And one of the interesting things we've done is see that standard move the needle both in terms of accessing cloud-based sources, but also starting to move the needle on what ODBC and JDBC capabilities people want to see coming in the future. So that's kind of interesting.
Very interesting. All right, so let's see. Let's talk about the database. Do you want to talk about the database wars since you're a Star Wars fan?
Yeah, absolutely.
All right.
The database wars is this idea that that history is repeating itself. Right. When we in the 70s and 80s, we had a couple of different databases that came out of some interesting research projects at IBM and UC Berkeley, involved into the standard relational databases with the schema model that we know and love today. Everything moved to a SQL-based query language, so that became common. And then in the early 90s, around 92, we said, hey, we need an ODBC standard. Between the ODBC standard in 1992 and 1999, we had a lot of databases starting to come up. You got MySQL and JDBC and all these new databases. And then when the bubble burst in 2000, we saw a rapid contraction of that. Right, a lot of the bigger players gobbled up some of the smaller databases, and we had something on the order of 4 or 5 major database players left in the market. Fast forward to just a few years ago, and there was this movement where people said those general purpose databases, Oracles, IBMs, those kind of databases aren't what we need anymore. They're not fast enough. They're not scalable enough. I need massive scalability across tons and tons of nodes. So you had ideas like Hadoop, you had VoltDB start springing up, and now you've got Clustrix and these cluster databases, and Cassandra and Mongo and HBase and Impala, and all of these sources are more specialty, more tuned towards one specific type of data access. Whether you're ingesting data, you're loading it really quickly, you're pulling it out really fast. The types of data that are involved are very different. And it's really interesting to feel like the database wars are happening again, right? There's this explosion of data sources. At some point, it's got to contract. We haven't seen a rapid contraction anywhere near what we had before, but we do feel like over the next 3 to 4 years, there is going to be some contraction in that. And as we see that come up, it's really interesting to see how ODBC and JDBC is still the standard of choice for your business intelligence applications, whether you use Oracle's products or IBM's products or something a little smaller like a Tableau or a Click, whatever you use, ODBC and JDBC are still those standards that people look to pull data out of those systems, but sometimes they don't match up really well. But that's the idea of the database wars is we're seeing this explosion of sources and variety and all these specialty types of databases coming up. It's really interesting to see people like Netflix using more than one in their application. They use a key value store for storing some of your voting information for your session, and then when they run their predictive analytics engine, to use a data sciencey term on you, when they run that predictive analytics, they store the results of what is recommended for you in something like a Cassandra or Mongo. I saw a really interesting presentation on how Netflix uses all these different sources, so it's very rare that you see a company that has one data source anymore within its borders, right, for its application. So as the database wars are coming on us again, there's this expansion of sources. At some point we're going to see it contract, but it probably will not contract back into just 4 or 5 big players like it did before.
On the topic of database wars, there's actually another kind of maybe a battle coming up. Like, what is a database? And you can see on this slide, there's a long list of data sources. Let's call them data sources. So you can see that open data standards are part of all of these. And I think that what I've learned is how you define a database. From a recent blog contribution I made to OData.org, I use a phrase to describe OData as being the ODBC or JDBC for the web. And the OData team shared that they prefer a broader analogy. They don't want to limit OData to just being about databases, which was what they assumed ODBC and JDBC were. Really what I realized is that we were really on the same page. We just had different interpretations on the scope of standards. So we think of ODBC and JDBC as being connectivity to your data sources, in other words, across big data, NoSQL, data warehouses, relational, even SaaS applications. And you can see the list on this slide. So it's it encompasses the entire spectrum of shapes and sizes of different data sources, which keeps our jobs really exciting and makes standards even more important. All right, so we're going to transition now into before we kick off our Q&A, we'll have I want to ask Jesse. He looks pretty smart. A couple of questions.
Okay, go for it.
Start off the discussion, and then maybe we'll give you guys some time to put your questions into the chat. But Jesse, so how are the standards evolving to keep up with all the new and various big data sources, since that's the topic of our webinar?
That's a great question. One of the things that we're working on, I sit on the JDBC expert group, and we've just recently been talking and meeting again, coming up for Java version 9, to come up with some changes to the JDBC specification. We're looking into adding in APIs for sharding. We've been discussing a bulk load API for a couple of years because ingesting data in there it's a big deal. I mean, a lot of customers are trying to figure out, when I use JDBC, I have a bunch of prepared statements, and I have to execute them either as a batch or standalone, and sometimes that really doesn't map to what they want to do, which is I have this huge amount of data. I just want to get it in the database as fast as possible. So we want to go, look into something like a bulk load. Another one is mapping. We're starting to look into how you're going to do data mapping across these data sources that don't have a relational model. So think of Mongo, for example. MongoDB does not have a relational model at all. In many aspects, each row can have its own schema. It's really odd. So how are you going to move that into a rectangular box, which is expected by an ODBC or a JDBC dataset? So having some common way to do mapping, because the way that everybody's doing it right now is we have mapping tools, or we can do it through a JSON description of what we want to overlay, and we can sample the data and come up with data types ourselves. But putting that control to the users in a proprietary way doesn't help people as much as if we bake it into the standard and we make it something that's easy to program once and then apply it not to just something like Mongo, but what about Cassandra or the next source that needs to have that mapping. That's kind of where we're going, at least in JDBC in terms of ODBC. But you're out in the field all the time. What are you seeing in the big data space around JDBC? Is there anything interesting going on there?
Yeah, along your point of big data ingestion, definitely seeing a lot of projects with JDBC connectivity for importing and exporting data. I get pulled into several Scoop conversations. NewSQL and Hadoop, I think, is what Scoop stands for. And we're moving, these customers or different users are taking massive amounts of data, they're crunching it, and they might deliver a terabyte to some relational system out of Hadoop and into that, maybe a SQL Server or Microsoft for Microsoft BI, or some other system, just whatever their customers want or whatever the end delivery system is. And that's a pretty slow process. When you take terabytes of data, you want to move it into some BI stack, and you may have to wait more than 24 hours for consumption. So that's really important to have those bulk features. And there are third-party JDBC drivers that handle this within the current JDBC specification, including the DataDirect drivers. And I think that one problem here is that there's clearly a lack of support for true bulk fetch in the standard itself. So if you're to write actual interfaces to do the bulk loads and fetches, that is missing from the spec. And actually, that's a good time to raise that question back to you, Jesse, since you sit on this expert committee. What's up?
There's actually a really good story there. I'll share it with you guys. So, bulk load originated within DB2 and Oracle, these Sybase, SQL Server, their client tool sets. Right? It wasn't something that was typical of a driver. So you would come in and you would say, I have all this data in a CSV file or an Excel file or something like that. And I want to get that data into my database and do some work on it. So what would end up happening is the database vendors found a way to have a bulk load protocol and have a tool with it. One of the things that we decided is that's nice, but the majority of the people who access the data in the database through a driver. So let's build that functionality into a driver. We went to the standards body. We actually wrote up some really interesting interfaces on how that should work. And that was right around the time when Oracle purchased Sun. So as Oracle purchased Sun, all this work that we had done in the standards body kind of ground to a halt for those of you that follow the activity out there. That activity kind of ground to a halt, and it's taken up until just recently for us to get back to the point where we're really going to try to start advancing the JDBC specification along those lines. But the good news is, even though it hasn't made it into the standard yet, that stuff is actively being worked on now. I'm guessing that at Oracle's conference in the fall at Open World, you'll probably see a JDBC session, maybe a Birds of a Feather session that we try to do every year, talking about those standards and what they're going to be adding in the next version of Java. So I would say look out for it there. It's coming.
Awesome. I have an interesting point about the bulk APIs. When we look at the SaaS sources like Salesforce and Eloqua and some of those, when you look at through JDBC, they actually have bulk inserts and exports, which we implement today, but again, that standard doesn't have it. And actually, that was one of the projects I forgot to mention. It was from Scoop. People are bulk loading data out to Salesforce for native reporting and other things like that. So really cool stuff. Do you accept bribes on your committee?
I accept all kinds of bribes, yeah.
Right.
One of the best ways to get in touch with us, for those of you who want to actually have some influence on the spec, is just to go out there to the spec's website. We can give that to you guys, send it out in a follow-up email. But then send us some emails and let us know. I mean, we all of the different standards body members belong to organizations that write drivers. So I meet with the guys who write the Oracle driver and MySQL, and we get together and we try to decide. We try to take off our hats, our corporate hats, which is difficult sometimes in that group of guys. We try to take off our corporate hats and look what's best for the individual application developer. So when we hear from you guys, the listeners out there, when you guys give us feedback, we take that to heart and we discuss every piece that we get. So that's a real good way to push something back into the spec.
All right, awesome. All right, Jesse, one more question for you. This is something I think about when standards. So more disruptive data sources are coming out. The shapes of data are changing. We're seeing document stores. We're seeing these really wide column databases. Not rectangular like the standards were developed around. How are the standards making this easier?
It's been like a trickle. It's not a fire hose of changes that are making it into the spec, but over the past few years there have been a few things that have gotten in there. So new data types. So look for XML data type support, JSON support. XML is the first, of course, for your hierarchical data. Lots of updates and changes to the lob interfaces. And other nested types. I know that some of the new database features, so features that the relational databases are adding, they're adding support for JSON data types here recently. So that's another thing that the specs may follow there a little bit. So as the JSON data type support is put into the databases, we might get an actual JSON type, put into the specification. So that would be the direction that we're going. So there's a lot of things, especially in the area of data types, that are making that easier on users who are trying to use drivers and these standards to get to their data. So I got a question for you, Sumit. As you're sitting in the field, right? What are you seeing around NoSQL types? MongoDB is a big one, right? What are you seeing in regards to these data types out there?
Yeah, MongoDB has been keeping me really busy lately with the standards-based connectivity talks. Actually, I've even share a little bit about some of the stuff I'm working on. Next week we'll be down in Atlanta at the Rittman Mead BI Forum talking about MongoDB analytics. I've got a MicroStrategy NoSQL webinar coming up later this month, and then next month, early June, we'll be in New York City for MongoDB World to continue the discussion. So I mean, I'm not just talking about what we do with the connectivity. I'm also sharing some of the things that we learned from doing this and some things to look out for when you're building standards connectivity to MongoDB. And this can be challenging, but it's actually one more interesting data source shapes that we've worked with in a while in the standards perspective. And just to give you a glimpse of, if you're not so familiar with MongoDB and SQL access to it, I'll just share a couple of use cases that I came across just recently. But we're working with a financial services company, and they're actually using MongoDB for cyber security purposes, and they track all the IP security details that come in and out of their network. And the groups there need to use Microsoft BI Stack. They want to create some reports in Excel or reporting services, and they want to access that stuff through a standard connector to MongoDB. They might set up the link server for a federation tier so that they can easily get that data in real time from MongoDB. So that was an interesting project and use case for SQL access. Another one, we're working with a group that's got an IBM order management system, and they are using MongoDB as a repository for different messages coming in and out, and they need to report against that using their favorite SAP connectivity tools. And that was a an interesting use case where NoSQL is actually supplementing a SQL system. So, the standard way to connect to both was really compelling for them. And then even things with the world of big data and clouds, some folks get these large dumps of data, and maybe they're doing clickstream analytics, looking at marketing ads and campaigns. They might just shove it up into a cloud Mongo Labs database or Modulus or something. It's pretty cost effective, and they can just plug in their favorite visualization tool, Tableau, Spotfire, Click, and just plug in the ODBC connector for standard access, and they're on their way. Those are some real-world examples. Some people get confused about some of the SQL on NoSQL terminology, but there are lots and lots of use cases, and I'm talking about them about every week now. And so that's some of the latest stuff happening in ODBC. But as a standard, ODBC dates back a couple of decades. Some people on the internet say it's as old as dirt. I don't read the internet that much, so I try to avoid reading that stuff. But anyway, Jesse, how in the world is an old standard like ODBC being trusted to pull these large volumes of big data at that scale?
All right, before I answer your question, I got a joke. I've got a joke, an ODBC joke. If you don't smack your forehead, this is great. So two ODBC developers walk into a bar. Then this bar is a big data bar. They leave 5 minutes later because they couldn't find a table. I know, it's awful, sorry, but had to share it because this is an ODBC big data question. Big data, there's no tables there, right? It's all file system based. But anyway, to go back to your question, how can you trust ODBC, this old as dirt API, to pull things like big data? Well, one of them, it is old as dirt. Dude, 20-year-old technology that is still relevant and being used in the world's hottest BI apps, like Tableau today, that says something for it. That's got staying power, Jack. We invented those standards to really be semi-future-proof, right? When we wrote them, one of the things that we wanted to do is take into account, streaming data, being able to have things modified over time, being able to easily manipulate what you've got behind the scenes, and just be very rich in metadata and able to be very flexible. So one of the ways that you can trust it is one that's been around for a long time. It's very solid. It's used by the world's biggest systems. And as we continue to move the standard forward, it's not dead. It might be old, but it's not dead. It's like that grandma or grandpa that you've got, right? That's going to outlast you all. That's going to be ODBC. So it's got a lot of staying power, and I think it's going to be around for a long time. The other thing that you need to realize is standards still drive technology today. You see it with Hive, with Cassandra, with the other big data databases and NoSQL databases, where they adopt things like ODBC standard types. Right? They adopt the same types that have been there forever. Why? Because that's how humans think. We think in these terms, and we just translated that into an API that makes sense for the way that humans want to deal with data for the most part, which is why SQL's still around. Now, some people hate it, and we'll get into that in a minute. But the interesting part is even the semantics of these types are built into the databases. Things, metadata, how you query that, all of that stuff actually came from ODBC. So that those specs are still influencing technology that's come out in the last 6 months, which is really, really cool to see. Now, some of the stuff that you see out in the field using, the standards, what are the challenges that people are seeing using these standards on top of the new sources?
That's a good question. So that when we look at some of these standards like ODBC and JDBC, and they're based on ANSI SQL standards, which are somewhat standard in themselves. So the challenges we run into are things like with Hadoop systems, these string data types can be up to 2 gigs. How do you expose that to your applications that aren't used to such large data types? So we see things where applications may not like the data type, and it might complain or not be able to do different operations on it, given the size. So one of the challenges is trying to map some of those big data types in some cases to what the applications like and expect, because some of these applications are, we're adding big data is new, and some of these sources are new, so applications may not have seen it yet. So there's some, the driver levels and the standards levels. Mapping data types is some challenges. Other things, different, call them windows into the Hadoop ecosystem, like maybe you have like a Hive or Cloudera Impala. I noticed that something like Impala has a different quoted identifier, and some applications don't like it. While the ODBC standard does tell you all these things, we're counting on in some cases, some applications may not be updated before you try the big data drivers, so you'll have to wait for a patch, but that's up to the connectivity vendors at that point to make everything work for you. And we've been doing that for a while. I guess there are standards, but then not everybody, you can't control people to follow the standards, and that can be a challenge.
Cool. So what about IoT? So Internet of Things, right? We're talking about big data here. IoT feeds directly into that, I would say. This is really hot. There's lots of discovery happening out there. I mean, you've got these new buttons from Amazon. You can put next to your Tide dispenser. You push the button, it automatically, will order you Amazon. A lot of interesting stuff happening in the IoT market. Have you heard anything about a standard there?
The IoT market, there's a lot of discussion. In terms of industry standards, it is new, a lot of discovery, but I think that the REST APIs are going to be popular in this space, and definitely OData is the leading industry standard here for REST APIs, but I can't predict that would be the one that would be adopted. I mean, I've also seen the OGC Sensor Things API that's specific to Internet of Things for consuming and producing IoT data from different devices and applications. It also uses a REST-like interface, but from where I sit and hear people talk, a lot of people today are staging some of this data in NoSQL databases or even a MySQL or some other some kind of database in between and then connect to it. But I'm sure that the standards will follow every step of that connectivity as we go forward and adopt some of that.
Very cool. OData is definitely used a lot. SAP, Netflix, Salesforce uses it, Microsoft. And, I work on the standards body, but you do a lot of blogging on OData.org. You're a member of the OData tribe. What do you see going on in that space?
It's really exciting. Definitely the OData tribe, the community are very enthusiastic about open standards. I also try to get them to coin that data hippie term because they're good people trying to do right for everybody. But it is the most popular standard, REST API, and it's definitely the most mature model for this industry. And Jesse mentioned some of the players in that ecosystem. You can check out OData.org to see who are the producers and consumers. In addition to us, there's SAP and Microsoft and different, and Salesforce recently added, I think back in November, has added OData as part of their external data strategy, which is great because they're a cloud application and they're opening up external data through a feed like OData. So it's really exciting for that ecosystem and a lot of movement going on in response to these vendors starting to support it, both as consumption and production. From a perspective of what I see on the ground, I know that some of the, definitely a lot of enterprises are having challenges with different sources of data. So they have, I think they have like a poor quality REST APIs that are non-standard, proprietary. They have to do a lot of work to maintain it. And so OData is something that different folks at these companies are trying to adopt. Another large organization we've talked to, they're looking at OData as a central strategy for their master data management solution so that as their workforce is more mobile, they might look at OData as a way to access that master data management system through both on-premise applications as well as those mobile applications. Actually, I've even seen some stuff from the Salesforce platform where they want to access Hadoop through their external data strategy. So that's kind of crazy. You don't have to move all of that data from Hadoop into Salesforce. You can actually access it through OData when you need it because big data isn't practical to move into other systems sometimes, and you don't always know what you want. So it's a great way to keep the data where it rests and expose it in a standard way. And from the OData tribe and some of my friends out there, I'm working with Mark Stafford and Yi Ding from that group, and they see some interesting challenges they share with me around low-quality REST APIs, and they're built by what they coined the term maybe REST API apprentices. So those people, they know how to deal with class models and from object-oriented backgrounds, but they're not as familiar with HTTP methods and definitions for paths and resources. So the community is working on tooling that can enable that REST API apprentice to design a REST API that follows OData conventions and just by stating a data model. So really the standard there is helping produce better quality APIs. That's similar to the standards we talk about, the ODBC and JDBC. They let us vendors build better innovation into those standards. And just like the end goal for all of these standards is, again, interoperability. And OData focuses more on the web and hybrid world. So that's an interesting space. And in a transition maybe from that OData conversation, Jesse, I've got a question for you. So for OData in the future, back to ANSI SQL, which is dated a little bit, even before ODBC, there's tons of back-end sources that don't support SQL. And many sources have their own query languages, whether it's SOQL or something else, and or maybe BSON for Mongo. And they have is SQL going to be the way of the dinosaur and die with these heterogeneous query languages that aren't based on SQL?
No, I don't think so. I'll tell you a couple of reasons why. I mean, I'll give you that. There's a lot of people who hate SQL. The whole NoSQL movement, brought out some real haters. But just because the language you're using is structured doesn't mean you can't query unstructured data with. It just means it was hard. It was a fun challenge to see a lot of the guys in the market come up with interesting ways to do mapping and to be able to take a SQL statement and deconstruct it in a parser so that you could, turn it into a SOQL statement or even a set of web APIs. I do want to pause here for a second and encourage you guys that are listening in. We're going to be hitting the question and answer session here in just a minute. So if you could go ahead and start typing in questions. Sumit and I, we've covered a gambit of topics. Anything from Internet of Things to big data to open standards and how it plays with Hadoop and mapping for Mongo. I mean, this is an opportunity. You guys start typing in questions, and we're going to be getting to those in just a minute. Speaking of MongoDB, we did build a driver for MongoDB, and a lot of stuff when you talk about the ANSI SQL and how that stuff plays in, Mongo is really hard. But by giving the power back to the user, which is one of the things that we're trying to do here, the use cases are so varied, we have to give a lot of control over those parsers and things so that they can fulfill the query requirements that they have by imposing a schema on top of that data in a way that makes sense for them. So I guess to answer your question on if SQL's going away, no, I don't think it is. It started to expand a little bit, and transform a little bit, but I don't think it's going to go away.
Okay. All right. Thanks for the SQL commentary. So I noticed in MongoDB, the driver you mentioned that we built, there's features for. So we built a driver with features for aggregation, and then MongoDB, at MongoDB World last year, then they introduced the aggregation framework. The standards expert building connectivity products, for rapidly evolving big data sources. How do you determine which features to build and when?
We listen. We listen to the people that give us feedback. Just like anything else, we want feedback from the people who are most concerned about it, the developers that are out there, cranking out code every day. We want to make it easier for those guys to do it. We have a history of driving features into the backends and the standards we support. Sometimes we lead, and sometimes we follow. Think of it like a dance. In this case, we led with aggregation. We knew it was something that was going to be important based on relational models from before, so we built that aggregation into the products and tried to get it in there, but it was already in the standard. It was just something that we applied on top of Mongo, and then Mongo followed. So that was a case where we were leading. The evolution of Hive and Paula Spark and Spark SQL. Hive left off support Hadoop left off support for SQL early on, but eventually realized that it was needed. Wrote Hive on top of it, and then by the time Spark came around, Spark SQL was right there with it. Right, so the SQL thing came right into the forefront. This is needed to support all those big enterprise app stacks that are used for business intelligence and making decisions every day. So as an R&D organization, we never have the luxury of waiting. Right? If we see a gap, we have to fill in that gap with technology immediately so customers can get the standards they want and make them behave in a way that makes it easier for them to code and to get that data out in a meaningful way. But like I said, it's a dance. Sometimes we lead, sometimes we follow. In that case, we were leading. So it's really fun to sit here and talk through this with you, Sumit. But I do want to open it up to questions. We have some people on the line that I'm sure have some interesting questions for us. So, Steve, are you still on? If you're still on, I guess we change it over to you guys, and we'll start taking questions in from the field.
Absolutely. Thank you, Jesse and Sumit. Before we open it up to everyone, one question for both of you. If you were the dictator and controlled the standards completely, ruling with an iron fist, what would you add for the big data ecosystem?
Oh, wow. That's a strong question. If I were a dictator ruling with an iron fist, Moe's every day for lunch, and then I would immediately move into finishing out the bulk implementation. I mean, that's one of the things that the JDBC expert group started on. ODBC has a streaming API, but moving massive amounts of data into and out of these systems is something that I think is paramount, and that's absolutely one of the things that we want to get. I mean, the bulk batch interface that we have today in the standard, it can be a bit clunky for that, especially when you look at being able to do data validation and high levels of streaming and parallelism and things like that in the bulk interface. That would be my number one. Sumit, what you got?
Yeah, I agree with that. Just add, make sure that includes bulk fetch. We talked about, again, the SAS APIs definitely have bulk fetch APIs for their different systems, and I know that can help make or break API calls if you're limited in those governed environments. So I would agree with that. Just add fetch.
Cool. Another one I'd like to see is some more metrics and metadata. Think about the CAP theorem, right? And given the self-service nature, given how big data operates, before I do an operation on a back end, I want to know the probability of a successful and fast execution. So something maybe like a built-in query analyzer, being able to ask the driver through the standards API, say, hey, how fast do you think this is going to go? Are there things that I can do to is it going to be fully consistent, or is it going to be eventually consistent? Is this going to hit multiple nodes or a single node? How can I gauge the success of that query, and can I ask metrics? I mean, I'll give you an example. Some drivers that support the bulk interface now have this idea of, before you do a bulk, say, can you validate? And what it'll do is it'll analyze the back-end source and analyze the data you're getting ready to ingest through a sampling mechanism. So we'll sample that data and then try to match it up with the back-end and say, hey, you've got these three data types out of whack, and the sizes here don't look right. So given some kind of indicator for success before I kick off a query that might take 2 hours, that would be one of the things on my wish list as well.
Ooh, that's a good one. All right, so let me think of one too. I think that's a really good one because, as a user, for me, if I'm able to do it, I'm going to try it, and someone needs to help protect me from breaking systems. But thinking about some of the interoperability of the latest applications, there's data visualization tools, exploration, even the new term data wrangling. I noticed that there's a lot of folks who need to just get a preview of the data. What does it look like? And give me just a couple of rows. And I noticed that in the SQL grammar, there's a lot of different limiting. There's top end clauses, there's limit, there's fetch first. It seems like every source has a different way of doing it, and then the REST APIs and things like that have their own ways to batch data. But a standard way, maybe another escape syntax. I know that there's a lot of interoperability in escape syntaxes in both specs, ODBC and JDBC. So I'd love to see one for row limiting clauses. And then another one would be awesome for me, and not me, but people I work with. I think would be nice is when you query some of the SaaS and cloud data sources, a lot of APIs have built-in governors or limits on how much you can query. Even some cloud services you query data from have governors and limits for different periods of time, including some are like a 24-hour rolling period. And if you exceed it, you're kind of done for the day. And I've seen that happen when at one point someone had a sync tool with Salesforce and MySQL, and it kind of they upgraded the MySQL database, and it was kind of infinite loop and blew out their Salesforce APIs, and they're kind of done for the day. Maybe leave home, go feed the dog. But one of the things that would be helpful there is to actually know, how many more API calls do I have? Give me some idea of like how, again, kind of Jesse's line, how risky is this query to our operations? I can make better decisions that way, especially since the trend is to get data in the hands of more people. A lot more data analysts and visualization people are out there, and this would really help those folks not be scared to do their work and blow up the system for everybody else.
Cool. All right, that's the end of my wish list. So if I were a dictator, I think that's what I'd do.
Okay, all right. And I would disagree with the Mo's, though.
Cool. All right, Stephen, let's get some questions from the audience.
All right, fantastic. Thanks, guys. Our first question from the audience today is OData a higher standard that includes ODBC, JDBC, JSON, and XML?
Okay, I'll take that one. So to answer that, OData can communicate in like the resources and the payloads are in XML or JSON, but I wouldn't say that it encompasses all the standards and all the data formats. We look at OData as being it's a standard REST API, and it's best suited for web and hybrid environments, whereas ODBC and JDBC are more focused on some of the SQL standards, maybe some workloads like in the big data space when you're doing analytics and BI and warehousing, things like that. So I think that they have served different purposes, and they're each useful for different projects. I wouldn't say one encompasses all of the rest. And one other kind of misnomer about OData is it's open data protocol. It doesn't mean that you open up data with OData and everybody in the world can touch it. There's still security involved, so you do have authentication and different strategies to get to that data, like in the case of Salesforce. If you pull out on-premise data from your back office firewall, there better be security on that before Salesforce touches it for their external data strategy.
Understood. Thank you, Sumit. Our next question, is there any connection between OData and OAuth?
Take that one. So sure, OData is a standard way to transfer data and query data across a REST connection, and OAuth is a standard way to authenticate over the web. So OAuth. To give you an example, OAuth, logging in via OAuth, you can do that with something like a Google, through Facebook. So when you go to a website and it says, "Hey, log in with your Facebook credentials," and then and then it pops up a little window and says, you type in, you log in with Facebook. It says, "Allow this application to mess with your Facebook stuff." So that's kind of the idea of OAuth, right? Both of them are standards. Both of them are standards for the internet. And one of them is a standards for transferring data, and one of them is a standard for authenticating. Good question.
Thanks, Jesse. Next question, is big data just something that data scientists should be concerned about? Why should anyone else in the organization care?
That is a good question, especially since a lot of people are talking about big data. And I think that actually, I went to a big data boot camp in New York last year, and one of the interesting presentations, big data ecosystem seems to change every week. So this is way back in the big data days, but the director of the CIA came on and talked about, when they would adopt big data. And the answer was that, they would start looking at it when they could, the word he used was democratize that data for everybody in the organization, right? So if big data is just useful for data scientists, that solves a very specific problem, but to really get more value out of big data, you really have to find a way to get it opened up for everybody. And I think that's where you see this big trend in the wrangling and the visualization of big data spaces.
Understood. Thank you, Sumit. Our next question, will the RDBMS go away and make way for NoSQL, parentheses, if customers prefer inconsistent read for their queries, knowing that eventual consistency will be there in a few minutes with NoSQL/Hadoop with products such as Cassandra, or will both coexist? Realize that's a bit of a loaded question.
It's a great question, though. I just finished up a class at MIT, a data science class, and this was a hot topic. People will agree and or disagree on this, depending on where you are, what conference you're at, and who you ask the question. But the way that it stands right now, relational databases are becoming more disadvantaged They were built on an architecture, that was basically to facilitate fetching large amounts of data from a platter, right? So it was actually a mechanical, physical reason why they had, row locking and the way that they do the database locking, table locking, and row locking, and the way that they do their paging and stuff for data that you fetch was all because you had to rotate these platters and move a mechanical arm in a hard drive. Now, fast forward 20 years, and those hard drives are going away. Everything's going in memory. You've got SSD drives. You've got, ginormous amounts of RAM. So one of the interesting changes, if you look at the designs of some of the newer NoSQL databases, they're actually designed to be single-threaded, which for you programmers out there, you're going to scratch your head and say, how in the world is single-threaded faster than multi-threaded for accessing a database? In this instance, what ends up happening is the locking that the relational databases go through to lock and make sure that the data is protected, that you're reading for that consistency that you want on the platter, it's actually faster to serialize the access to the data and eliminate all that locking code and just do it in order, because it's so much faster to access it off of RAM or an SSD drive. So is it going to go the way of the dinosaur and make way for NoSQL? It's definitely a contest right now. The other thing is analytics are huge. Analytic workloads and stuff are most efficiently run over columnar type databases, right? So you look at something like like a Vertica Sybase IQ, or that actually changes how the data is progressed, and it's built for analytical workloads. Well, a relational database is going to have a hard time keeping up with that. So for the time being, they're going to coexist. 10 years from now, if the relational database guys don't start changing their fundamental architecture, they are going to start to lose out. I mean, the market, if they were perfect now and could meet all these use cases, then the little guys, these little specialty databases, wouldn't have any legs to stand on. But their use cases are proving out, so that's a big deal. But great question. I think that if they can't change, then yes, they'll go away. But if they get innovative and rework their architecture in such a way that they can start to behave more like these NoSQL guys, then they're the ones that have bajillions of dollars, and they'll eventually gobble up the little guys, and they'll stay afloat. That's my prediction.
Understood. Next question. Big data requires lots of data movement. Will ODBC be able to handle this more efficiently, or do we need to look at specialized connectors such as Scoop, TPT, bulk loader?
All right, that's a great question. I think it plays well with some of the discussion we've had here around the future of the standards, because we did talk about the need for big data movement for big data. So I think when you decide on maybe a tool versus a standard, there are different things like under this coverage, Scoop is a JDBC connection. TPT, the Teradata Parallel Transporter, uses ODBC sources in a lot of cases. There's definitely native bulk loaders. So to answer your question, I think that there are cases where it's going to depend on the target data source and which connector you use. But the connectors that Jesse's team builds with ODBC, they do support transparent bulk load. So they're going to take data that's being streamed from whatever big data system and stream it right into the database. And with big data, I think that's really important, because if you start getting the business of dropping flat files and moving them to a different server and then running a script, that kind of kills the scalability of your architecture, and that's really important with big data systems. So I would look at it more as maybe not with ODBC as the right standard, but think about which project you're running and make sure you have the right ODBC driver and right data source. I think that's a good follow-up question. If you have a specific project in mind, we can answer more specifically.
Understood. Thanks. And as a follow-up question, how does Scoop relate to standards like ODBC and JDBC or OData?
So from my experience with Scoop, it's open source. You can take a look at the code. It's JDBC in its API, but it does support some. I believe it has an ODBC interface, but it's natively JDBC, and that's what most of the projects I see that I get involved in, or I see going across the Scoop user group. As far as OData, I have not seen Scoop read and write with OData. It's very possible it has. I just haven't seen it. I know that some of the ETL tools out there, like I know Microsoft SQL Server Integration Services actually has an OData extract as a source. So I have seen that, but I have not seen with Scoop.
Understood. Moving on to our next question. Companies have spent lots of money and years standardizing on analytics products like Cognos or Qlik. Does big data just make all that investment moot?
Absolutely not. I'm reminded of Hadoop World last year or the year before. Guy got up on stage and started talking about Hadoop and all the benefits of Hadoop, and his quote was, we just spent about $1.2 million over the last couple of years building our business intelligence stack for our company. So now we get visibility into all these different parts of our organization. Managers are making good decisions. We're being able to see clearly into requirements and needs from our customers, and now we have Hadoop and I can't get to it, right? How do I tie in big data into a Cognos or a Qlik? And standards connectivity is exactly what that's for. Right, you look at a Cognos or a Qlik, and they're built on ODBC. Any ODBC driver that you have can plug right in. So the first thing you need is you need an ODBC driver that supports the big data backend that you want, whether it's an Impala or a Hive or a Spark or whatever, and then you can plug that into those. You do have to realize that how you build your queries is very important when dealing with a Hadoop backend. Hadoop backends have high latency, so make sure you do some performance testing and pick something that's going to tune and make sure that map reduction is just as efficient as it can be.
Understood, Jesse. Thanks. On to our next question. Is the bulk load protocol anything like Salesforce's bulk API?
It's a great question. The answer is yes. So when you think about bulk protocol and the bulk API, right? So the bulk API that we're looking to build into JDBC is going to just be an interface, a set of calls that you're going to make in Java. Now, what happens under the covers today, Sumit was talking about bulk load earlier, with the different tools that support that, they have a protocol that they speak to each backend. In the case of Salesforce, it's Salesforce's bulk API. So you will use the bulk API in JDBC on top of a JDBC driver built to Salesforce, and under the covers we will auto-magically use the Salesforce bulk API. If you were using something like DB2, you would use the DB2, the bulk API on top of a DB2 driver, and we'd use the DB2 bulk API under the covers. So that's the relation between the two. The bulk load protocol will either be a wire-based protocol for some of your relational sources, or some type of load tool protocol, or in the cases of a SaaS source, it'll have a bulk load API, and in this case, Salesforce's bulk API would be it.
Understood. Our next question. There are lots of offerings in the big data space, and consolidation is bound to happen. How can picking a standard for connectivity help protect an organization's investment?
That's a good question to think about future-proofing your big data investment. And the way I look at it, I don't think about it as picking necessarily a standard, but I would choose a set. Everything you connect to, you should use industry standards. So I wouldn't say you should pick ODBC and JDBC over OData or something like that. But what we've seen is a lot of shops have, they start along the road with big data. They may have started with maybe Hive servers and then have some of the low latency and high latency mix of components in the Hadoop ecosystem. So you might have Hive, you might have something like Impala and Spark and all these different pieces out there. And they all do behave a little differently. So it's really the best advice is to choose a standard and then also choose a connectivity for that standard that keeps interoperability in mind. That's something that Jesse's team takes very seriously, making sure that your application experience through those standards against those different pieces of data sources in Hadoop and big data are consistent. So we've seen it time and time again where someone might they might have some kind of marketing automation system or some kind of security system, and it may have in the past may have been used to using like a data warehouse, maybe an enterprise data warehouse or MPP architecture. And when they switch it over to something in the Hadoop world, things may not work as well. And just having a standard connectivity shop, including Jesse's team, to make that stuff work out of the box, it's really important. So again, I wouldn't choose a specific standard, but I would definitely recommend using all three standards where it makes sense, and also making sure you choose make a wise decision in terms of interoperability of those standards, because not every connector in ODBC or JDBC is implemented the same, right? A lot of them are built just specifically to that source, whereas we believe in building them to be open and interoperable for everybody.
Understood, Sumit. On to our next question. NoSQL products like MongoDB are gaining a lot of adoption. How can an organization make sure data in MongoDB or another NoSQL product doesn't become an island?
That's almost a loaded question. I paid this guy to ask this question, I'll bet. Yeah, the answer is use open standards. One of the things that we're talking about here is making sure that your data doesn't get locked away in some silo, is making sure that you can be able to access it from just about anywhere. So the whole purpose of using these open standards for data, whether it's ODBC, JDBC, OData, is to make sure that that those silos don't exist, that you'll be able to use a driver to be able to get to any of those sources and any of that data, no matter where it is. Great question.
Understood. Thanks, Jesse. And how can an ODBC or JDBC solution really work with a technology that doesn't use SQL, like MongoDB or Cassandra?
That's also an interesting topic that I actually enjoy talking about. For things like MongoDB, I think a couple of years ago there was a group of graduate students from NYU that actually built a MongoDB connector, and I read their write-up, and they had a semester to build it, I think, or maybe a year for their project. And they said there were definitely some inherent challenges with building ODBC driver on top of the unstructured and semi-structured MongoDB data model. But again, that was when you have a team focused on it, beyond a project, and you have a lot of experience with like Jesse's team. We do a lot of unique things and some patent pending things to make that stuff work. So with MongoDB, I think our strategy with a lot of these disruptive sources that may not have support SQL on the back end, is to make sure that the connector, the driver, ODBC or JDBC, makes the right decisions. It can take a SQL query and push down as much as it can to the back end database. And then it's also capable of handling some things that it may not be able to push down. And so those are some of the strategies we've taken to make that work. And then things like Cassandra, that's a different engineering challenge. And those nodes can grow infinitely, and you get some partition keys, and there's a lot of things. It's not always as simple as doing a SQL query. So the drivers have to be, the vendors have to know the data sources and know the challenges, and there's a lot of work that goes into building these things. So from the perspective of an end user using one of these drivers, it should be, the goal is to make it so you don't really know necessarily or care what you're talking to, and that's what the bazillions of lines of codes these guys write around here to do that.
Understood, Sumit. That's actually all the time we have for questions today. We apologize that we were unable to get to all your questions, but as I stated earlier, all questions will be answered via email. I'd like to thank our speakers today, Jesse Davis, Senior Director of Research and Development at Progress DataDirect, and Sumit Sarkar, Chief Evangelist, Data Connectivity and Integration at Progress DataDirect. If you would like to review this presentation or send it to a colleague, please use the same URL that you used for today's live event. It will be archived for 90 days. Plus, you will receive an email tomorrow once the archive is posted. And if you would like a PDF of this presentation, you can click on the resource icon at the bottom of your console. Now, as we stated earlier, just for participating in today's event, someone would win a $100 American Express gift card, and the winner today is Bill Corey. Bill, we will be in touch via email so you can claim your prize. Thank you, everyone, for joining us today, and we hope to see you again soon.